Hi, are you planning to deploy DeepSeek on Amazon EKS with an optimal architecture? Yes, we are going to deploy DeepSeek vLLM on Amazon EKS Auto Mode using GPU and Inferentia instances. Let's get started. In this module, you will learn the following topics: how to build and deploy an end-to-end solution architecture for hosting DeepSeek vLLM on Amazon EKS Auto Mode cluster using GPU and Neuron based EC2 instances. How to design networking for Amazon EKS Auto Mode cluster that includes VPC and subnets, and then create Amazon EKS Auto Mode cluster. You will also learn how to create custom Karpenter NodePools for GPU and Inferentia based EC2 instances. We will build container images for DeepSeek vLLM and push it to Amazon ECR repo. And then finally, we will deploy DeepSeek vLLM model on GPU and Inferentia based EC2 instances. We will also create a container image and then deploy chatbot UI based on popular Gradio user interface application. Finally, we will test the DeepSeek model by interacting with some simple prompts. In this module, we will learn how to design end-to-end solution architecture to host DeepSeek vLLM model in Amazon EKS Auto Mode cluster on GPU and Inferentia based EC2 instances. Let's get started. We will first create Amazon EKS Auto Mode cluster. Amazon EKS Auto Mode fully automates Kubernetes cluster management for compute, storage, and networking on AWS with a single click. It simplifies Kubernetes management by automatically provisioning infrastructure, selecting optimal compute instances, dynamically scaling resources. Amazon EKS Auto Mode continuously optimizing costs, managing core add-ons, patching operating systems, and integrating with AWS security services. The EKS Auto Mode comes with default Karpenter NodePools, which are pre-built into the managed Karpenter. The first one, general purpose NodePool, which is used for all the general purpose workloads which do not need any specific instance configuration or requirements. The second one, system NodePool, which is used for all the add-ons, controllers, operations, daemon sets that are used by all the applications across the cluster. We cannot modify the built-in system and general purpose node pools. You can only enable or disable them. Apart from the default node pools, we will also create custom Karpenter node pools, one for GPU based EC2 instances and second one for Inferentia or Trainium based EC2 instances. The node pool specification allows for fine-grained control over EKS clusters compute resources through various supported labels and requirements. These include options for specifying EC2 instance categories, CPU configurations, availability zones, architectures RM64 or AMD64, and capacity types EC2 spot or on demand. You can also set resource limits for CPU and memory usage, ensuring cluster stays within desired operational boundaries. And then we will deploy two variants of DeepSeek vLLM, one for GPU and other for Inferentia based EC2 instances. DeepSeek R1 is an open source AI model specifically designed for reasoning tasks and problem solving. It excels in logical inference, mathematical problem solving, and complex reasoning, aiming to provide step-by-step solutions. R1 is based on reinforcement learning and uses techniques like chain of thought prompting, where the model thinks out loud to arrive at answers. vLLM, that is Virtual Large Language Model, is an open source library designed to optimize the inference and serving of large language models, that is LLMs. It addresses the computational challenges of running LLMs efficiently, especially at scale, by using advanced memory management techniques. We will also deploy chatbot UI based on popular Gradio user interface application. This will create an application load balancer for end users to interact with. Gradio is the fastest way to demo machine learning model with a friendly web interface so that anyone can use it anywhere. In this module, we will learn how to create Amazon EKS Auto Mode cluster using infrastructure as code tools like Terraform. Let's get started.
Hi all, in this lab, let us understand how to create Amazon EKS cluster for AML workloads. So, we will be creating one EKS cluster by name AML Auto Mode 1. Okay. So, this is completely based on Amazon EKS Auto Mode, and we'll be deploying few custom Karpenter NodePools as well, apart from the default NodePools. Okay. So, before we first get started on creating the cluster, we must understand the design of the VPC and subnets.
To operating an Amazon EKS cluster, we require knowledge of both AWS VPC networking in addition to Kubernetes networking. We need to understand the EKS control plane communication mechanisms before you start designing VPC or deploying clusters into existing VPCs. We will create a VPC with CIDR size of /16, which will have around 65,000 IP addresses. This is the maximum size for a VPC CIDR. The reason for such a large CIDR is that machine learning and generative AI applications can scale up to thousands of pods. Each needs a dedicated IP address. We will create 3 private subnets for data plane, each with a size of /18, which is 16,000 IPs. So we will have a total of 48,000 IPs across 3 availability zones. These IP addresses are used by both worker nodes and pods. As a best practice, I would recommend creating dedicated subnets for control plane and data plane. In this case, for a demo purpose, I am using same subnets for both control plane and data plane. Also, as of now, the managed Karpenter in Amazon EKS Auto Mode uses the subnets specified during cluster creation for default node pools. So we need to ensure that there are enough IP addresses in those subnets for pods and worker nodes. For public resources, we will create 3 public subnets for data plane, each with a size of /24, which is 256 IPs. So we will have a total of 768 IPs across 3 availability zones. These IP addresses are used by application or network load balancers and NAT gateways. For databases, we will create 3 private subnets for data plane, each with a size of /25, which is 128 IPs. So we will have a total of 384 IPs across 3 availability zones. These IP addresses are used by self-managed or AWS managed databases. Apart from these private and public subnets, there are still free IP addresses up to 16,000 which can be leveraged in future. Please note, VPC and subnet design is a very subjective decision and must be carefully planned based on organizational requirements and constraints. Amazon EKS Auto Mode also supports adding additional CIDRs to the VPC to further increase IP space and avoid any IP exhaustion challenges. Amazon EKS Auto Mode extends AWS management of Kubernetes clusters beyond the cluster itself to allow AWS to also set up and manage the infrastructure that enables the smooth operation of your workloads. You can delegate key infrastructure decisions and leverage the expertise of AWS for day-to-day operations. Cluster infrastructure managed by AWS includes many Kubernetes capabilities as core components as opposed to add-ons such as compute autoscaling, pod and service networking, application load balancing, cluster DNS, block storage, and GPU support. EKS Auto Mode dynamically adds or removes nodes in EKS cluster based on the demands of Kubernetes applications. This minimizes the need for manual capacity planning and ensures application availability. EKS Auto Mode is designed to optimize compute costs while adhering to the flexibility defined by NodePools and workload requirements. It also terminates unused instances and consolidates workloads onto other nodes to improve cost efficiency. If the workload requires changes to storage, compute, or networking configurations, you can create custom node pools and node classes using EKS Auto Mode. While default node pools and node classes can't be edited, you can add new custom node pools or node classes alongside the default configurations to meet specific requirements.